A lens mu is equal to 1.5 is coated with a thin film of refractive index 1.2. In order to reduce the reflection from its surface at lambda 4800 angstrom, find the minimum thickness of the film which will minimize the intensity of the incident light. Now when I consider over here a lens, and suppose its refractive index is given as 1.5, and suppose over here it is covered by a thin coating of refractive index 1.2. okay, now when I consider this part, okay, this small part over here, okay, now the thickness is very small, so instead of a curve it will almost seem to be a straight line. Okay, it will almost seem to be a straight line. Now when I consider a incident ray, okay, when it gets reflected, there will be a path difference of lambda by 2. यहाँ पे lambda by 2 का path difference होगा. Okay, because the light is getting reflected, and this is the third layer is air, which is that is the light is passing from rarer to denser medium. Okay, so light is getting reflected from rarer to denser medium, so there will be a path difference of lambda by 2. Now this will continue, okay, and again it will get reflected. अगर यहाँ पे again if I consider between the incident ray and this ray, there will be a path difference of lambda by 2. But now if I consider between this ray and the ray that is reflected second time, I can say that the path difference will be equal to mu t plus or 2 mu t. Basically it will be equal to plus lambda by 2. Okay, it will be equal to 2 mu t divided by plus lambda by 2. So now over here it will be equal to 2 mu t plus lambda by 2. So if I consider this part, okay, we have to find out such that it forms the minimum thickness such that it forms lesser intensity or lower intensity as compared to the first one. So basically it is very much clear that in order to get the lower intensity or less intensity, the path difference should be in the multiples of lambda by 2. Okay, the path difference should be in the odd multiples of lambda by 2. So now when I consider, it will be equal to, let us find out the path difference. It will be equal to 2 mu t plus lambda by 2 minus lambda by 2. Okay, minus lambda by 2, it will be equal to 2n minus 1 lambda by 2. Okay, so basically lambda by 2 will get cancelled out. 2 mu t will be equal to 2n minus 1 lambda by 2. So they have asked what is the minimum thickness. Okay, for minimum thickness n will be equal to 1, so it will be equal to lambda by 2. It will be 2. Refractive index over here, for the first one, the refractive index over here will be equal to 1.2, okay, into t. The thickness over here is unknown, okay, and the wavelength is given as 4800. Okay, if I substitute the wavelength over here, it will be equal to 4800 divided by 2. Okay, it will be equal to 4800 divided by 2. Okay, so now when I substitute the value over here, okay, it will be equal to over here, T will be equal to, this is in angstrom. Okay, this is in angstrom, so it will be equal to 4800 divided by 1.2 divided by 1.2 into 2, 2.4 divided by 8 will be equal, divided into 2 will be equal to 4.8. so basically the thickness will come out to be, equal to 1000 angstrom. This should be the thickness of the coating.